Hello, my name is Ana Sofia Landeros, and in conjunction with Chris Lorena Amelia Torres Bautista, Eitan Aracanchi, and Francisco Cantu, we worked on this article, which is Population Density, Health, Education, and Dwelling Quality Effects on Social Life Status of Mexican Localities. In the next slide, you'll be seeing the agenda for this presentation.
Hi, my name is Eitan Aracanchi. So in this presentation, we'll be first talking about the problem which will be addressed, what is the context of this problem. Then we'll make a data understand where the data came from and making an exploratory data analysis to better understand it. Then do a basic data preparation like removing missing values and checking on the data types of the data, and then making a feature selection to understand what is the contribution of each factor to explain the social lag index of each locality. Then the modeling part consisted on testing each classification model accuracy to detect which classification model is the best one to be used for the classificator. Then the evaluation part consisted on comparing the real data versus the prediction and see how well these predictions behave comparing to the real values. And finally, we'll make a conclusion and the extensions of this work. So what is the problem addressed in this analysis? Well, it's to understand how the factors composing the social lag of localities behave and explain the social lag status of the localities. So what is the relationship of this social lag status with the dwelling quality, health, and education aspects of each locality? So we want to understand how these factors is contributing to these welfare aspects of the localities and be able to better understand this phenomenon. The purpose of this analysis is to understand the impact of each component on the social lag index, also adding some demographic consideration like the total population of the localities. So the contributions would be to have a classification model on the social lag index status of localities and be able to make some predictions based on education, dwelling quality, and health aspects.
So when looking into the problem context, social lag is an indicator that measures social development in Mexico, and it takes into account economic and social aspects represented by 11 variables. In Mexico, 30% of municipalities have a high or a very high social lag, and nearly half of the population is living in multidimensional poverty, and 1/10 of the population is living in extreme poverty. Multidimensional poverty is considered a multifaceted phenomenon that takes into account aspects related to living conditions that threaten the dignity of people and limit their rights and freedoms. This is where this multidimensional index known as the social lag is considered. The social lag index was proposed by Coneval as a multidimensional index which considered both economic and social aspects represented by 11 variables that contemplate education, health, and dwelling quality aspects complemented with population information at locality levels. And it was also one of the first social lag status classificators in Mexico. Now we will look into the origin of the data. The data that was studied in this project comes from a multidimensional poverty measurement study by Coneval in Mexico, using data from the Intercensus Survey of 2020. The information of population and social lag with their 11 composing factors for the 108,149 Mexican localities is presented in this database. The 11 variables composing the social lag index are the following. The social lag index is calculated utilizing component analysis from the weighted sum of 11 variables representing the percentage of population per municipality enjoying or not access to education, health, and living condition facilities. Then we go into the exploratory data analysis. First, we can observe the data frame, which shows the 11 composing variables for the social lag index. Then we go into the first analysis, which was the histogram. The histogram shows a skewed distribution to the left. This skewed distribution is asymmetrical because a natural limit prevents outcomes on one side, and it also restates that the majority of the social lag index is located between -1 and 1. Then we have the box plot, which essentially shows the skewness, and it also allows the visualization of the outliers, which are shown after the fourth quartile, and it also restates that the majority of the social lag index falls between -1 and 1. Then we look into the violin plot, which is also considered a combination between the box plot and the density plot, and from this we can also observe the outliers and the the healthy representation of this distribution. Then we look into the correlation from feature selection. The objective was to perform a correlation assessment on the dataset attributes. Most of the variables are positively and strongly correlated to the social lag index. However, there are two variables, which are total population and population without access to health services, which were close to zero, meaning that there is no association between these two variables and the social lag index. When the values of the Pearson correlation fall between 0 and 0.15, this means that there is no correlation or association. The most important variable that shows no correlation would be, in this case, the population without access to health services, because it was usually expected for this variable to fall in a high correlation. Yet this could be possible due to having localities with a high social lag index in cases where people had access to health services, but they did not have access to other aspects lacking either education or basic infrastructure in housing, or quality services and space in housing, and so on.
So the data preparation part consisted first on understanding the data types to be able to know how to handle each variable and process it adequately. So most of the variables are float variables, being a percentage of localities having a specific welfare aspect, and some object variables. And then the missing data part was checked to see how much missing data was present in the data set, remove it, and then finally having a data set without missing values. And then the creation of the social lag status variable was made based on the category of the social lag from the social lag index value, where a category of social lag being very low, low and medium corresponded to a negative social lag status, meaning that the locality don't have a social lag, and a high and very high category of social lag would be a positive social lag status. The feature selection part consisted on doing an ordinary least square regression to understand how each factor was significant, explaining the social lag variability. And as seen, all the variables and the factors considered in the analysis were significant in explaining the social lag variability. But on the other hand, when checking on the correlation between each factor to the social lag, it was seen that the total population of localities correlation was not significant. But on the other hand, It's important to consider all the variables in the analysis because all the variables were significant explain the social lag index variability, even if the total population was not significantly correlated to the social lag.
Looking at the performance of the models using occurrence mean, it can be said that the best classifier is SBM. When looking into the box plot, it can be said that both logistic regression and SBM have the highest ROC ACC scores, and both are good options. Logistic regression and support vector machines are supervised machine learning algorithms, and both are used to solve classification problems. Logistic regression and SVM with a linear kernel behave similarly, but depending on the used features, one may be more efficient than the other. The decision tree is a model with the lowest accuracy score. It is not a bad accuracy, just lower than the other 5 models, and they are often inaccurate, and there are other models that have better performance using similar data. So the difference between SVM and logistic regression is that the first fits the best distance between line and the support vector that splits the classes, reducing the risk of error found in the data. One of the main reasons why SVM is considered the best model, even though they both have high accuracies, is that the SVM method has a lower risk of overfitting than logistic regression, which is very vulnerable to it. So after selecting the SVM model as the best classification model, the weights of the SVM were used to obtain the relevance of each parameter with respect to the status of social lag, or the social lag status. Greater weight in a parameter, greater importance or contribution it has to predict whether or not there is social lag in the locality. From the weights, we see that most of the variables have adequate relevance with respect to the social lag status. The most relevant feature is AP. This means that the greatest contribution to predicting whether or not a locality has social lag is the illiterate population. This is a condition that causes gaps in education and access to opportunities for a life in full freedom and with access to job opportunities. Not having the ability to read and write can close life opportunities. We can also see that all the variables related to housing condition have a high weight in the prediction of the social lag in localities. Housing conditions are closely related to the economic condition of a household and are directly related to poverty conditions. If we turn to pi variable, proportion of 15 years old and older people with incomplete basic education, it is one of the parameters that has a weight similar to dwelling or housing, and it is directly related to the proportion of the illiterate population. In Mexico, more than 8.9 million citizens over the age of 15 have not completed their basic education programs, which seriously prevents them from applying or obtaining jobs in the administrative branches of the private and public sectors. If we look at the graph, TP and PWHS are the only two parameters that have a drastically low weight coefficient, almost zero. Obtaining a low or zero weight does not exactly mean that the parameter itself does not contribute to the definition of the lag status index. But it tells us that for this linear model of SVM, the classifier obtains a good prediction without these parameters by using other features.
The evaluation part consisted on using a prediction dataset of 21,500 observations to make the predictions on the social lag status of the localities. So by seeing the histogram, it can be seen that 12,000 negative social lag status were predicted against 9,500 positive social lag status, which in some way behaves according to the proportion of localities with positive and negative social lag.
So, when looking more distinctively into the predictions and the real data comparison, we can see that the predictions follow a very similar behavior to the real data, as shown in these bar graphs. Looking into them more accurately, the most important insight from this would be that they have a very similar pattern with an accuracy in the predictions of approximately 99.83%. And the output values are obviously from this binary variable are 0, which means that there isn't social lag, and 1 that where there is social lag. And from this result, the most predominant value in both predictions and actual results is 0, with similar behaviors more than half in both cases, showing that they do have a very distinctive pattern.
Okay, in conclusions, the linear SBN model was trained and selected as the best classification model. A feature ranking was applied to obtain the relevance of the social lag determinants and see which of them are the ones who contribute more to predict the social lag index of a locality. Illiteracy, dwelling conditions, and basic education are the main determinants of social lag index status. Locality population and population without access to health services were the only two parameters that presented a low weight coefficient, meaning that for this linear SBN model, these two parameters are not necessary, and it is a good classifier by only using the other 10 determinants. High social lag, poverty, and inequality are the combination of undesirable factors associated with the lack of growth and development of Mexico. The SBN model of this project proposed measuring or predicting the effectiveness of public policies for social development in Mexico in terms of social lag index status. Applying this model gives a more precise picture of social lag, and it is a useful tool for generating social policies addressed to localities in need, with the support of predicting what would happen if those policies are applied. For further research, it would be interesting to study other variables that could affect the social lag of the population besides the variables analyzed in this project. That is, take into account other variables apart from the 12 that build the social lag index, and use them for a classification model. Also, other classification models could be applied for higher accuracy and better prediction. Implement a PCA analysis to complement future extraction. Likewise, we studied localities, then it would be interesting to perform analysis of grouping states and municipalities according to their social lag to find new insights and trends. And finally, it could be really interesting to implement the expected value analysis. First, we would like to thank the audience of this conference. Also, we would like to thank the School of Engineering and Science at Tecnológico de Monterrey and the National Council on Science and Technology of Mexico, CONACYT, for academic and financial support. We want to acknowledge the Tecnológico de Monterrey for the support on tuition and CONACYT for the living support. We would like to thank as well as the Coneval for providing the data for this analysis. And finally, we would like to thank to Dr. Francisco Cantu and Dr. Hector Ceballos for their guidance and tools provided for this project. Thank you.